Today we're going to learn how to perform an independent t-test using SALT. An independent t-test is one where you have data on two populations, and the data values for one population do not affect the data values from the other one. This is different from a paired test where you can pair the before and after values to one individual or something like that. Here it's different. The data values for one population do not relate to the other one at all. So let's take a look at our data to test whether women score higher than men on average on the verbal section of the SAT. So this data set looks a lot like what yours will. Each row represents one person, their verbal SAT score, their math SAT score, and then whether they're female or male. So one way of calculating easily the important things we need, such as the mean standard deviation for women and men, we need to sort by column C. So we can sort, expand selection based on column C. And now we have all of the women's scores followed by all the men's scores. So first, let's compute the average verbal score for women. So we type equals average, and we highlight on the verbal section till we have all the scores of all the females who took the SAT in this sample. And it might take you a few seconds, but if we get that, we find out the average comes down to 602.7.07. Okay, now we need to calculate the standard deviation for the women who took it. So it equals STDEV.S over the same scores. We find that the average is 102.0. We can do it similarly for men. So for men, the average verbal SAT score from our sample is 590.38. And the average standard deviation comes out to about 97.18. We also need to know how many females and males were in our study. So one way to find that is the sample size, and we can use the COUNTIF function. We can look at column C and ask, what is a female? We find that there are 82 females in the study. Similarly, we can find out the sample size for males by using the COUNTIF function over column C, asking for when it's equal to M for male, and there are 80 males in this sample. Notice that for an independent t-test, the two populations don't have to be the same size in your sample. Well, we can take this to SALT now. Under inferential statistics, we look at two sample T, and the sample mean for women was 602.07. The standard deviation was 102, and the sample size was 82. The sample mean was 590 for men, 0.38, 97.18 for the standard deviation, and the sample size was 80. The null hypothesis would say that there is no difference, and we want to know if women are greater than men on average. We're not going to assume equal variances because we're not sure. And we generate results, and we get a p-value of 0.228. So what that indicates is that is bigger than our level of significance. And so we do not think that there is enough statistical evidence to conclude that the average SAT score of women for the verbal section is higher than men.